to discuss very important topic, that is in permutation and combination only, that is circular permutations. That is circular permutations. That is what? Circular permutations. Circular permutation. In previous section already we discussed, that is linear permutation. Linear permutation means if we arrange all the possibilities of an event, if we arrange all the possibilities of an event in a straight line, then it is called a linear permutation. With repetition, without repetition, how to find the linear permutations already we discussed in previous video. But here we discuss circular permutations. Circular permutations. Circular permutation means definition. If we arrange all the possibilities of an event, if we arrange all the possibilities of an event in a circular manner, if we arrange all the possibilities of an event, if we arrange all the possibilities of an event in the form of circle or a circular manner, then it is called what? Circular permutations. Definition: if we arrange all the possibilities, all the possibilities of an event, if we arrange all the possibilities of an event in a circular manner, or in a circular way, then it is called circular permutation. Circular permutation means definition what? If we arrange all the possibilities of an event, if we arrange all the possibilities of an event in a circular manner or in the form of circle, then it is called what? Circular permutation. Circular permutation. If we arrange all the possibilities of an event, if we arrange all the possibilities of an event in the form of circle, is called what? Circular permutations. In the form of circle is called what? Circular permutations. That means in this circular permutation, observe here, if we arrange all the possibilities of an event, that means if you take A, B, C, D, in this circular permutations, we have two ways. That is, if you take A, B, C, D, E. If you take A, B, C, D, E, these A, B, C, D, E, arrange all the possibilities in the form of a circle. This way is called clockwise direction. This is clockwise direction, or this is anti-clockwise. This is anti-clockwise direction. Circular permutation means what? Circular permutation means if we arrange all the possibilities of an event in the form of circle. If we arrange all the possibilities of an event in the form of circle or in the form of circular manner, that is called circular permutation. In the circular permutations, we have two arrangements, that is clockwise direction and anti-clockwise direction. But if you see this clockwise direction and anti-clockwise direction, in circular permutations, direction is very important. These two permutations considered as two permutations. In the circular permutation, both are different permutations according to directions. This is anti-clockwise direction, this is clockwise direction. If you take this is A, B, C, D, E, this is A, B, C, D, E. This is anti-clockwise direction, this is clockwise direction. These considered as two circular permutations. Circular permutation means if we arrange all the possibilities of an event in the form of circle. If we arrange all the possibilities of an event in the form of circle, is called what? Circular permutation. In the circular permutations, we have two arrangements, that is clockwise directions and anti-clockwise direction. Clockwise directions and anti-clockwise direction. Clockwise direction and anti-clockwise direction, we take two permutations. If we some special cases, clockwise direction and anti-clockwise direction treated as one direction. Some special cases only. Let us discuss which are the some special cases treated as only one direction means. Let us discuss next. First of all, these two permutations are called circular permutations. That is clockwise direction and anti-clockwise direction. Let us discuss small example. Let us discuss one example. How to describe the circular permutation, how to find the number of circular permutations by using of general method. So, let us discuss one example here. Write down all circular permutations by using the digits 1, 2, 3, 4. By using the digits 1, 2, 3, 4. In the first one, taking 3 at a time. And second one, taking all at a time. Observe here. Write all the circular permutations. By using the digits 1, 2, 3, 4, taking 3 at a time, taking all at a time. Right, first one, solution. Taking 3 at a time. So, by using of these three digits, we describe the circular permutations. We write all the circular permutations. Already we know that circular permutations means if we arrange all the possibilities of an event, in a circular manner, then it is called what? Circular permutation. So they gave the digits 1, 2, 3, 4. Let us take 1, 2, 3. The possibilities, first possibility is take 3 at a time. Taking 3 at a time is, let us take 3 digits 1, 2, 3. Right off, circular permutation here means, that is, taking 3 at a time means, clearly 1, 2, 3. This is one permutation. And 1, 3, 2. This is second permutation. Next, take again three possibilities, that is 1, 2, 3 is completed. Take 1, 2, 4. 1, 2, 4. Right here. 1, 2, 4. And second one is another permutation. Here direction is Direction is very, very important. That is 1, 4, 2. Completed. 4 completed. Next, take another 3 digits. Next possibilities, that is 1, 2, 3 completed. 1, 2, 4 also completed. Take next 3 digits, that is 1, 3, 4. Right? 1, 3, 4. Next one is, that is 1, 4, 3, 1, 4, 3. We get 1, 2, 3, 4, 5, 6. Next, take next 3 possibilities, that is 2, 3, 4, right? 2, 3, 4. This is 2, 4, 3. So, write all the circular permutations, by using the digits 1, 2, 3, 4, 1, 2, 3, 4, by taking 3 at a time. If you write the possibilities, first possibility is 1, 2, 3, taking 3 at a time, 1, 2, 3. That is circular permutation is clear as 1, 2, 3. And this is which direction? Clockwise direction. And anti-clockwise direction is also 1, 2, 3. We get 2 permutations. Next, take another 3 possibilities, that is 1, 2, 4. 1, 2, 4 right here. 1, 2, 4. This is clockwise direction. Right? 1, 4, 2. This is anti-clockwise direction. We get again 2 possibilities. Next, take another 3 numbers, that is 1, 2, 4 completed. Next, take that is 1, 3 and 4. Take 1, 3, 4. 1, 3, 4. This is which direction? This is clearly clockwise direction. 1, 3, 4. Take another direction, that is anti-clockwise direction. 1, 3, 4. So we get next one. Next, take another 3 digits. That is 2, 3, 4. 2, 3, 4. This is 2, 3, 4. This is clockwise direction, and 2, 4, 3 is anti-clockwise direction. Total we get number of circular permutations. We have 1, 2, 3, 4, 5, 6, 7, 8. Total we get number of circular permutations is equals to 8. Therefore, number of circular permutations is equals to how much? In the total number of permutations is how much? 8. Now we want number of permutations of, write all the circular permutations of taking all at a time. Taking second one, that is taking all at a time. Taking all at a time. Taking all at a time means the digits 1, 2, 3, 4. Taking all at a time. By using of these 4 digits, how many ways we arrange the circular permutation means? Observe here. 1, 2, 3, 4. That is first one is. This is 1, 2, 3, 4. This is clockwise direction. Take anti-clockwise direction. That is 1, 4, 1, 4, 3, 2. That is 1, 2, 3, 4. Anti-clockwise direction. Completed. 2 completed. Next one. Take 1. Change the 2 objects, that is 1, 3, 4, 2. 1, 3, 4, 2. This is clockwise direction. Anti-clockwise direction is 1, 2, 4, 3. 1, 2, 4, 3. 1, 2, 4, 3. That is 1, 2, 4, 3. Next. Change the again. 1, 4, that is 1, 4, 2, 3, right? Anti-clockwise direction, that is 1, 3, 1, 3, 2, 1, 3, 2, 4. So, this is 1, 2, 3, 4. This is clockwise direction clearly. Anti-clockwise direction is 1, 4, 3, 2. If you change 3 and 4, we get 1, 3, 4, 2. This is clockwise. Anti-clockwise is 1, 2, 4, 3. Next, 1, 2, 4. Next, if you change the places of 2 and 4, we get 1, 4, 1, 4, 2, 3. This is clockwise. 1, 3, 2, 4 is anti-clockwise. So we get 1, 2, 3, 4, 5, 6. We get number of circular permutations is equal to, we get here, we get 6 circular permutations. So write all the circular permutations. Write all the circular permutations by using the digits 1, 2, 3, 4. How to write the circular permutation means by taking 3 and 10 means consider 3 digits 1, 2, 3. The circular permutation, that is 1, 2, 3. This is one direction, and that is clockwise direction, and second is anti-clockwise direction, that is 1, 2, 3. Take another 2 digits, another 3 digits, that is 1, 3, 4. Take 1, 3, 4 right here. 1, 2, 4. Take 1, 2, 4 digits, that is 1, 2, 4. This is clockwise direction, anti-clockwise is 1, 2, 4. Take another 2, that is 1, 3, 4. 1, 3, 4. Right, 1, 3, 4. That is anti-clockwise is 1, 3, 4. And take another 3 digits, 1, 2, 3, 4. 2, 3, 4 and 2, 4. This is, we get 8 circular permutations. 8 circular permutations. So, circular permutation means what? All the possibilities of an event. All the possibilities of an event. All the possibilities of an event. Right? In circular manner. Circular manner. Or all the possibilities of an event. All the possibilities of an event arranged in a circular way. Circular way. That is called what? Circular permutation. If you take all at time, this is, we get 1, 2, 3, 4, 5, 6 circular permutation. If you take it all at time. So this is general process. By using of this process, if they gave the number of, they gave the digits 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Find all the circular permutation means, if you draw all the circular permutation, somewhat difficult to find the number of circular permutations. So how to find the number of circular permutations of n different things is given. Taking all at a time, let us discuss, that is theorems. First theorem, that is first theorem. The number of circular permutation of n different or n dissimilar things, the number of circular permutations of n dissimilar things, the number of circular permutations of n dissimilar things taken all at a time is clearly n minus 1. So already we discussed in previous example. So how to find the number of circular permutations? If number of objects, number of things, if more, to draw the circular permutation somewhat difficult, and find the number of permutations. How to find the number of permutations? By using of drawing of circular permutations somewhat difficult. So how to find the number of circular permutations? By using n dissimilar things, taking all at a time means. All at a time means we use this formula, that is clearly n minus 1. N minus 1 factor. So the number of circular permutations of n dissimilar things. The number of circular permutations of n dissimilar things taking all at a time is clearly n minus 1 factorial. N minus 1 factorial. N minus 1 factorial. How much? N minus 1. Proof. Let us assume that number of circular permutations of let us assume that number of circular permutations of n dissimilar things taken all at a time is equals to f. Let us assume that number of circular, we don't know how many number of circular permutations. So number of circular permutations of n dissimilar things taken all at a time is what is considered as m. That is it. So in that m circular permutations, consider one circular permutation, that is right towards here. That is A1, A2, A3, A4, A5, and so on, an minus 1 and a. We have n dissimilar things. If we array all the possibilities of an event, taken all at a time. So we don't know how many number of circular permutations forming means we don't know that number. So let us assume that the number of circular permutations of n dissimilar things taken all at a time is m. We don't know that. So let us assume that the number of circular permutations of n dissimilar things taken all at a time is how much? M. In that m circular permutations, consider one single permutation, that is A1, A2, A3, A4 and so on, an minus 1 A. So this single permutation, this single circular permutation gives rise to n linear permutations. This single circular permutation gives rise to n linear permutation. This single circular permutation, this is only one single circular permutation. This single circular permutation gives rise to n linear permutation. Why? Because if you cut this chain, we get A1, A2, A3. That is A1, A2, A3, and so on. An minus 1 comma an, one linear permutation. If you come here, if you disconnect this circle, we get one linear permutation. Or if you disconnect here, we get another linear permutation, that is A2, A3, A4 and so on, an comma A1. If you disconnect here, we get another circular linear permutation, that is A3, A4, A5 and so on, A1 and A2 and so on. If you disconnect here, we get an comma A1 comma A2 comma and so on, that is an minus 2 comma an minus 2. So we get how many linear permutations? Single circular permutation gives rise to n linear permutations. That is 1, 2, 3, 4 and so on up to n. So single circular permutations, single circular permutations gives rise to n linear permutations. Single circular permutation gives rise to n linear permutations. We have how many circular permutations? N circular permutations. So single circular permutations gives rise to n linear permutations. So n circular permutations. So n circular permutations gives rise to m into n linear permutations. M into n linear permutations. Single circular permutations gives rise to n linear permutations. We have m circular permutations. So m circular permutations permutations gives rise to m into n linear permutations. M into n linear permutations. We know that the number of linear permutations of n dissimilar things taken all at a time is clearly npn is nothing but n factor. Already we know that we discussed in previous classes the number of linear permutations of n dissimilar things. The number of linear permutations of n dissimilar things taken all at a time is clearly npn is nothing but n factor. So we have m into n linear that is m into n linear permutations is equals according to problem that is m into n linear permutations is equals to gives rise to n factor. M into n linear permutations gives rise to n factor. So we want m. So m is equals to n factorial by n. M is equals to how much? N factorial by n. N factorial is nothing but n factorial can be written as n minus 1 factorial into n by n. Clearly n and it cancel. So we get n minus 1 factorial. So m is equals to m is what? M is the number of circular permutations of n dissimilar things taken all at a time is m. So m is equals to we get n minus 1 factorial. Observe here the theorem. The statement of theorem is the number of circular permutations of n dissimilar things. The number of circular permutations of n dissimilar things taken all at a time is clearly n minus 1 factorial. N minus 1 factorial. How to prove this theorem means observe here. Let us assume that we don't know how many number of circular permutations they found means. Let us assume that number of circular permutations of n dissimilar things taken all at a time is. Let us assume that clearly m or take x or k. So number of circular permutations is equal to how much? M. Or take x also or take k also. So that is m. In that m circular permutations, consider only one single circular permutation. That is one single permutation. Observe this figure. Taking one single circular permutations, if you take means this single circular permutations gives rise to n linear permutations. Clearly, n linear permutations. If you disconnect the circle here, we get A1, A2, A3 and so on, an one linear permutation. If you disconnect the circle here, we get A2, A3, A4 and so on up to an and A1. That is second linear permutation. If you disconnect the circle here, we get next one. So single circular permutation. So single circular permutations gives rise to n linear permutations. How many? N linear permutations. We have already m circular permutations. So single circular permutation gives rise to n linear permutations. So m circular permutations gives rise to m into n linear permutations. Single circular permutation gives rise to m linear permutations. We have m circular permutations. So m circular permutations gives rise to m into n linear permutations. We know that the number of linear permutations of n dissimilar things. The number of linear permutations of n dissimilar things taken all at a time is nothing but npn. Npn is nothing but n factor. The number of linear permutations of n dissimilar things taken all at a time is clearly n factor. But according to problem, m into n linear permutation is equal to n factorial. We want m. M here means what? The number of circular permutations of n dissimilar things taken are n at a time, all at a time. That means we want m. So m is equals to, if you transpose m here, we get multiplication quantity here, multiplication quantity that comes to division quantity. So we get here m is equals to n factorial by n factorial by n. Already we know that n factorial can be written as n minus 1 factorial into n. N minus 1 factorial into n. In denominator already we know. So n and n get cancelled, we get n minus 1 factorial. So the number of circular permutations of n dissimilar things taken all at a time is n minus 1 factorial. N minus 1 factorial. Let us discuss some small example. Yes, one example. Observe here. Find the number of ways. Find the number of ways arranging five boys and 5 girls around a circle. Observe here. Find the number of ways arranging 5 boys and 5 girls. 5 boys and 5 girls around a circle. Solution. Observe here. Solution. Number of boys is equal to 5. Number of girls is equal to Number of girls is also 5. Number of boys is equal to 5 and number of girls is equal to also 5. Total number of things or objects or persons. Total number of persons is equal to 5 plus 5 really 10. So n is equal to how much? 10. N is equal to. We want the number of ways of arranging. 5 boys and 5 girls around a circle. That means we want circular permutations. So the number of we know that the number of circular permutations. The number of circular permutations of n dissimilar things taken all at a time is equal to n minus 1 factor. Already we discussed this. The number of circular permutations of n dissimilar things taken all at a time is clearly n minus 1 factor. So the number of ways arranging 5 boys and 5 girls around a circle is clearly n minus 1 factorial means 10 minus 1 factorial, that is equal to 9 factorial. 9 factorial is clearly how many ways? 9 factorial. Observe here one example. Find the number of ways of arranging 5 boys and 5 girls around a circle means. Observe here. 5 boys and 5 girls, total number of persons is equal to total 10. So n value how much? 10. We want arranging the circular permutation. Around a circle means we want number of circular permutations. Already we discussed on theorem, that is the number of circular permutations of n dissimilar things taken all at a time. The number of circular permutations of n dissimilar things taken all at a time is clearly n minus 1 factorial. So here n value how much? 10. So the number of ways of arranging of 5 boys and 5 girls around a circle is nothing but 10 minus 1 factorial. 10 minus 1 factorial is nothing but 9 factorial. So 10 minus 1 factorial is nothing but 9 factorial. Yes, very very important. Observe here. One more. In case of happening of the circular permutations of the circular permutations like in the case of happening of circular permutations like, that is garlands of flowers, chains of beads, and so on, etc. In case of happening of the circular permutations like garlands of flowers and chains of beads, etc., they look like in two arrangements, that is clockwise arrangements and anti-clockwise arrangements as identical. Look like clockwise arrangement and anti-clockwise arrangement. Clockwise arrangements and anti-clockwise arrangements are identical. That means both are same. Already we discussed in previous. That is, in case of happening of the circular permutations of like garlands of flowers or chains of beads, etc. They look like clockwise direction and anti-clockwise direction. Observe the chains and garlands of the flowers, chains of the beads and garlands of the flowers. Clockwise direction and anti-clockwise direction look like identical. That means same, both are same. So in that special cases, circular permutations are treated as both direction as single permutations. So clockwise direction and anti-clockwise direction, both directions treated as only single permutations. So in that cases, number of circular permutations, number of circular permutations of n dissimilar things taken all at a time is equal to half of n minus 1 factor. Half of n minus 1 factor. In this case, that means in case of happening of the circular permutations like garlands of flowers and chains of beads, etc., clockwise direction and anti-clockwise direction. Clockwise direction and anti-clockwise direction look like identical. That means same. So in this special cases, circular permutations, clockwise direction and anti-clockwise directions considered as single permutations. So how to find out that means number of circular permutations in garlands or chains of beads? Number of circular permutations means we get n dissimilar things taken all at a time. We get half of n minus 1 factorial. That means half of the total n minus 1 factorial by half. That means consider taking only one direction, that is clockwise direction or anti-clockwise direction. If you take only one direction. Why? Because in garlands of flowers and chains of beads, clockwise direction and anti-clockwise direction considered as single permutations. Both are same in these cases. So the number of circular permutations of n dissimilar things taken all the time is half of n minus 1 factorial when garlands of flowers and chains of beads, if you take, that is half of the n minus 1 factorial. Half of the n minus 1 factorial. Let us discuss one example. Yes, let us discuss one example. Observe here. Find the number of different ways. Find the number of different ways of preparing. Find the number of different ways of preparing a garland using 7 distinct red roses. Find the preparing a garland using 7 distinct red roses and 4 distinct yellow roses, such that no two yellow roses come together. No two yellow roses are come together. Solution of the result. Find the number of different ways of preparing a garland. Find the number of. So they gave number of 7 red roses. Number of red roses is equal to number of red roses is equal to 7, and number of yellow roses is equal to, clearly they gave 4 yellow roses. They gave one condition, that is 4 distinct yellow roses, such that no 2 yellow roses are come together. No 2 yellow roses are come together. That means any 2 yellow roses not at all come together. That means we want a circular permutation. This is circular permutation. First arrange the red roses in a circular manner. That is red rose 1. R2, we have 7, R3, R4, R5, R6, R7, that is R3, R4, R5, R6, this is R7. First we arrange the red roses in a circular manner. How many ways we arrange the red roses in a circular manner? Circular manner means clearly 7 minus 1, 7 minus 1. In between gaps, we arrange 4 distinct yellow roses. How many ways these gaps to fill this? By using of 4 yellow roses means, how many gaps means? First count them 1, 2, 3, 4, 5, 6, 7. We have 7 gaps. How many ways to fill these 7 gaps means? By using of 4 distinct yellow roses, that is clearly 7p4. 7p4. So, but this is the preparing a garland. Preparing a garland means the total arrangement is clearly 1 by 2 times of 7 minus 1 factorial into 7p4. That is clearly 1 by 2 times of 6 factorial into 7p4. So, total number of ways is equal to, therefore, total number of ways is equal to 1 by 2 times of 7 minus 1 factorial into 7p4. That is equal to 1 by 2 times of 6 factorial into 7p4. Observe here. How many ways preparing a garland? How many ways of preparing a garland? By using of distinct 7 red roses and 4 distinct yellow roses. Such that they gave one condition, that is no 2 yellow roses come together. No 2 yellow roses are come together. Means first we arrange the red roses, 7 red roses in a circular pattern. How many ways to arrange these 7 roses, 7 different red roses in a circular pattern means 7 minus 1 factorial. Already we discussed, taking all at a time, n minus 1 factorial, that means 7 minus 1 factorial. In between gaps, why? Because 4 distinct yellow roses, such that no 2 yellow roses come together means any 2 yellow roses not at all come together. So that's why every yellow roses can be fit these gaps. 1, 2, 3, 4, fill these gaps. How many ways to fill these gaps? To fill these blanks by using of 4 distinct yellow roses means we have 1, 2, 3, 4, 5, 6, 7 gaps. So already we know that. How many ways to fill these 7 gaps? By using of 4 yellow roses means 7p4. 7p4. But this is preparing a garland. This is already we discussed. Preparing a garland or preparing a chain means by compulsory divided by 2. So 1 by 2 into 7 minus 1 factorial into 7p4. Clearly, 1 by 2 into 6 factorial into 7p4 is the answer. No two yellow wedges are come. No two yellow wedges are come together. Means clearly 7p4 rays. This is 7 red wedges get arranged in circular manner, that is 7 minus 1 factorial. But this is preparing a garland, so we use 1 by 2. 1 by 2 times 7 minus 1 factorial into 7p4. That is 1 by 2 into 6 factorial into 7p4. Next